If we don't stop this, civilization is going to come to an end.
And they say, oh, look, it's hot outside. And I go, just because your ass is sweaty doesn't mean there's climate change.
All of us are amateurs here. But the scientists are saying this is scary.
And economists and politicians, and they're all full of garbage, okay?
Yeah.
Scientists operate on a higher level, but they're still people. And people, I don't care how diligent you think everyone is, people are still subject to peer group pressure. And we just saw the great experiment during COVID. So welcome to this debate sponsored by Zero Hedge and JM Bullion. This debate is about global warming and related topics. So since Dave is, shall we say, slightly skeptical of the global warming thesis, Dave, maybe you could talk about what you think the main points that people may not know. You're obviously quite gifted in science and matters related to skills you would need to analyze this. But I think a lot of people feel like the debate on global warming is quote unquote settled, sort of like they thought it was about COVID. But obviously you've got a different viewpoint and perhaps you could share it. And if you wouldn't mind, could you touch on one area that I'm particularly interested in, and that is how solar activity affects the cloud cover and temperature, and what solar minimums might mean to the whole process. All right, take it away, Dave.
You couldn't possibly skip that. If Steve and I missed that one, we've not done our job. Quick, my origin story. I believed completely. I'd ask other scientists. They'd say, "Yeah, climate change is real. I'm not an expert. No problem." One day I was sitting with the Secretary of Energy having lunch, actually, and he mentioned it, and I said, I'm agnostic, and he flinched, and I said, well, it would take 10,000 hours to understand the problem. And then I got pestered by a couple of people and said, how do you know it's true? And finally I said to one of them, no credible scientist doesn't believe it. And he said, yes, they do, and he sent me names. I expected to get names from some guy from Sheboygan State College, from the Department of Who the Hell Cares, right? And it was going to be, and it was not. They were prominent scientists. And I expected to then find out that they actually had just torched a model, and that doesn't mean it's not real. And that was not true. And so the first big fib, which is always a red flag for me, is the idea that there's no prominent scientists who don't believe it. There's some exceedingly prominent scientists who don't believe it. So, then that 97% poll is a lot of hooey. So climate scientists who cite that poll are either ignorant or lying to us. Neither warms my heart. I think the malincentives are huge. They're talking about tens of trillions of dollars. And the minute you bring money in, all of a sudden, it just mucks up everything. Because
that's one point. Dave, I haven't had a chance to disagree with you yet so far. On that particular one, I see a lot of people say, oh, they're doing it for the grant money. Now, anybody who makes that case has probably never applied for a government grant because it's the most
tedious, I have.
Tedious, boring, and normally unsuccessful venture you can possibly do. Mm-hmm. So people say, oh, all the scientists have been corrupted by the money. They're doing it for the grant money. They know they've got to say it's happening, so that's the results they'll get. Holy hell! I've applied for 9 government grants throughout my career. I missed out 9 times. That cost me 1.5 years of my life. And if I just simply spent the 1.5 years writing, I would have been just as successful. So anybody who thinks scientists are in it for the grant money has no bloody idea. A, that the universities get the money, not the academic. B, it's incredibly tightly monitored, so all you can do is use it, for your field trips or conferences and stuff like that. And 40% of the money universities take as an overhead. So the whole idea that they're being corrupted by money is just nonsense. Now, on the other side, of course, if you get, if you start saying what the oil companies like, you might get some consulting money out of that. I think Bjorn Lomborg is in that case. But yeah, it's not that money has corrupted it. I think it's the academic system itself is so bureaucratically overladen that you get, lousy results coming out of attempts to save government money. So if Elon Musk wants to save some money, I'd get rid of the grant scheme and say, give people money based on their performance and potential. But that particular argument that scientists are in it for the grant money. If you say that, you just don't know what you're talking about.
Well, so the problem is you're speaking from the perspective of an economist, and I'm not sure the grant money is that big in that world. In my world, research groups run anywhere from a small handful up to 150. And so the money gets very, very big in my world. And so if you want to be a prominent scientist, I always ran lean and mean with a group of around 10, but we're talking $1 million+ a year. And so the malincentive is that to get that money, I happen to not be in climate science, which is good. And I love the fact I'm not in a politicized science, but I still have to convince peers that that somehow I'm going to save the world in some way, that opening paragraph. And what is true is they're spending trillions of dollars, not necessarily amongst the scientists, but the solar panel makers and things like that. So there's literally trillions of dollars at stake in keeping this discussion
On both
moving
sides, because the
forward.
oil companies are making tens of trillions. So,
Well,
money,
let
if money wasn't here, we'd be having a sane debate. No argument there. Okay. But it's because there's so much
let,
wealth involved in this whole issue, wealth
It
and
clutters
potential
it.
destruction of wealth, and that does corrupt the debate. And
well,
that's why I think,
let's rather than
let's
talking
compare it to
about.
sorry, Bill. Yeah.
I was going to say maybe what we could do is rather than talking about whose incentives there are outside of the orbit of the scientists that you're talking about, maybe we could get at the heart of where you two might disagree on how much of this is man-made and it's an emergency, and how much of it is the sun and it's not an emergency. I mean, I assume there's some disagreement between the two of you, and maybe we should get into that part, because I think a lot of people. I think the mood of the country now is a little bit more that, well, maybe everything we thought about things we thought we knew about wasn't exactly true, as we learned in COVID. And so I think it would be worthwhile for people to see where you guys differ on that broad topic I just brought up.
Okay. Dave, I'll let you take the lead there.
Well, so good plan. Where do I start? You'll hear people repeatedly talk about the increasing violence of weather events as an indication of climate change. And there really is almost no data to support those assertions. And whether you're using data out of the IPCC or whatever, there's gobs and gobs of data that say not only is there not a trend, not a big trend, but there's no discernible signal in the trends. And so you can look at frequency of hurricanes or tornadoes, or you can actually look at the energy put out by the tornadoes, or you can look at all sorts of events within the climate. And the ones that supposedly are going to destroy the world, they don't exist. The big trends don't exist. The only thing you got that looks like a serious trend is Michael Mann's hockey stick, which has been so completely destroyed by even his own co-authors.
Because the temperature data records are, I think, incontrovertible. If you look at the recorded temperature, has risen by about 1.5 degrees over pre-industrial levels. And there's, if you're disputing that, you're going to be disputing measurement gauges. It's the
I don't dispute that.
Sorry?
I don't dispute that.
Well, okay, so that's the story. What we have had is a massive increase in, well, a 1.5 degree increase in global temperature, and that's people don't actually think that's massive. I think they think the problem is that we apply our thinking about the differences in temperature across the planet right now, and even across a single day, and think, what's 1.5 degrees? It's nothing. I think that's the basic attitude a lot of people have, because they're not trained to think about temperature over time. And they say, well, Florida's 10 degrees warmer than New York. Its income's about 20% lower. So if we had a 10 degree increase in temperature, it might reduce GDP by 20%. That's in fact what Nordhaus himself has done, as you'd be aware, Dave. But it's ignoring it's treating temperature across space as the same as temperature across time. And that is a huge mistake. That's what I think a huge amount of the people in the finance sector are doing. And economists have amplified that, because that's precisely what they've done.
So,
with the temperature across... Go ahead, Bill.
Steve, let me ask a question. Dave, the same one to you. Steve, I think you cited basically a 100-year time frame, plus or minus, in your, about temperatures having risen 1.5%. Um, what though is the what is the right perspective to use? Because I'm not an expert, but I've read plenty of, there's so many cycles and cycles within the cycles. While 100 years is a long time for each of us, it's not even a rounding error in anything related to the Earth's time. So, and the other question of that is there any distortion relative to the fact that some of these temperature monitoring devices appear to be closer to maybe
No,
warm
no, that's bullshit.
cities?
No, that
And
particular
that's
argument
okay.
is bullshit. Because
Can you
scientists, I
expand
mean,
on why it's bullshit?
if you work with scientists, and I do work directly with scientists, they're anal. Okay, there's a tendency when you work in scientists, you're up with detail, and if you find there's a detail you haven't got right, you get obsessed with that particular detail. So yes, there's a possibility that temperature, heat islands can cause an error in the recording. And if you have that pointed out to you as a scientist, you'll spend your time working out how do you compensate for that effect? How do you remove it? And equally, where you'll locate your, because we had a dramatic increase in the number of temperature sensors we have over time as well. Partially that's just because we all want to know the temperature where we are, so there are temperature gauges all across the planet that way, but also because of global warming, scientists have been locating buoys that can measure temperature in the ocean, and they're putting them in various isolated locations around the planet as well to get as accurate a measurement as they can as possible of the actual level of the global temperature. And again, in terms of what causes that to rise, the fact that carbon dioxide retains heat has been known for about 150 years. That goes back to 1859, I think, and a female scientist who first discovered the effect that if you shone light through this is light that includes infrared, obviously, through a cylinder with nitrogen, no increase in temperature, with oxygen, no increase in temperature, with carbon dioxide, the temperature rose. So the empirical effect has been known for going on 2 centuries. In fact, the actual mechanism is a semi-quantum mechanical mechanism. It's quite complicated. And only in the last year has somebody gone through and done, the group of scientists have gone through and said, what is the actual quantum mechanical process that means that infrared light of a particular frequency gets captured by a carbon dioxide molecule, and then it's actually the vibration characteristics of the molecule. I've got friends like a guy called Tim Garrett, who's the world's leading expert on, wait for it, snowflakes. Okay, he's the guy who understands the dynamics of snowflakes, and he's been through explaining it to me. And largely the explanation was the mechanical nature of the carbon dioxide molecule, because what you have is carbon in the middle and 2 oxygens on either end. It's a bit like a dumbbell with a middle weight, and when hit by a photon, and this is how the infrared light hits you. We had ultraviolet and light and visible light frequency coming in, reflected by the Earth back out as infrared. So you get an infrared photon hits that structure, it vibrates as part of being hit, but it's also captured as a photon captured by the molecule temporarily. And then when it's released, it can go in any of 360 degrees, like it's a sphere, come out any particular direction. So what that means is with less carbon dioxide, more infrared might just go straight back into outer space again, and the planet doesn't warm. The more the carbon dioxide you add, that captures a proportion of the molecules of the photons coming out and then reflects them in any particular direction. So it slows down how fast that photon leaves the planet, and therefore it warms the atmosphere up as it goes out. And the main greenhouse gas is actually water vapor. But as we all know, the hotter it gets, the more water vapor the air can contain. It's about 7% per degree. But it falls, well, it falls out of the sky as rain. So a water molecule being added to the atmosphere, boosting the increase in temperature from carbon dioxide itself, will not last long unless the temperature is maintained higher. So carbon dioxide plays like a long-term regulator role. That's been known for, as I said, 150 years. And when you then, and the puzzle was, why is the effect of it logarithmic? So if you increase the amount of carbon dioxide in the atmosphere linearly, you get a logarithmic increase in temperature. And what we've actually been doing, and this goes right back to 1750, I've done the stats on this, the level of carbon dioxide in 1750 was roughly 278 parts per million. And if you fit a simple exponential to that, what then happens after that, it's been an exponential increase from 278 parts per million to 420 or 30 now over time. And all the policy waffle we've done for the last 40 years has done bugger all to change that trend. It's just been going on for that length of time. So what you've got is an exponential increase in the temperature with a logarithmic effect of the rising levels. So what you get is a linear increase in temperature, and that's been sustained for the last 60 or 70 years when you look at the data change. So the causes are definitely carbon dioxide generated by humans, and even down to the level what scientists do to examine this. Again, I'm not a scientist, so I don't know I'm getting the right number, but there's two main isotopes. I think carbon-13 and carbon-14. As it happens, the one that we generate is carbon-14, I think. I'm not sure of that particular detail. Science papers will tell you, but they say that's the one that's whose proportion has been increasing in the atmosphere. So it's not volcanoes, it's what humans do. We've added to the temperature of the planet. And this has the long-term regulation of the temperature of the planet is largely controlled by a feedback system between carbon dioxide and other influences.
At JM Bullion, excellent service and competitive pricing aren't just goals, they're our standard. Our commitment to customer discretion and privacy with secure and confidential transactions has earned us an unparalleled reputation as an online retailer of precious metals, backed by over 375,000 reviews, averaging 4.8 out of 5 stars. Only at JM Bullion.
What they're called Milankovitch cycles and so on. So we've had 150 years of slowly rising temperatures, but as we increase that exponential level of carbon dioxide, we're starting to get to the point where the planet itself is starting to release carbon dioxide. So we're getting carbon dioxide and methane coming out of permafrost. And the scare that people have is if we push this too far, we start to trigger other changes which amplify the changes we've set in place. And the two biggest worries people have is a reduction in albedo from the falling amount of ice in the northern, particularly in the northern hemisphere, but also the AMOC, what's called the Atlantic Meridional Overturning Circulation. And the great worry is that if we trigger one of those parts of the climate to tip, then that's end of civilization stuff. Again, this comes down to what models predict and what paleontological data has shown. But the most recent paper I've seen on this front, and it freaked me out when I saw the numbers, said if the AMOC goes, then the average temperature in the northern hemisphere will fall by up to 20 degrees, and the average in the southern will rise by up to 20 degrees. Now, if you have those sorts of changes, you can forget about civilization continuing. And the real reason that climate scientists are demonstrating now and locking themselves to the doors of Shell and stuff like that, they think if we don't stop this, civilization is going to come to an end. And that's the area where the attitude of scientists is completely different to people in the finance sector. And I'm afraid in this case, it's the people in climate who are the experts, not the people in the finance sector.
Okay, Dave, what do you have to say about that cheery prognostication?
You dismiss the heat island effect completely?
Yes, I do. I know too many scientists. I don't work with the people who do the actual measurements.
Well, I
work with
people
who work in tipping points. But no, they are anally careful about how they record data. There would be a tiny impact and reduced over time. And if you look at if you look at the recorded data, we now have data which is proxy data. You've got to have all sorts of proxies once you go before we had any measurements done. We have proxy data going back 540 million years. Okay, and that data shows you what it shows. And this is I might actually show a chart here because I think it's important for people to see the context in which we evolved. You know the Milankovitch cycles, Dave. I'm sure.
Yes.
Okay. Well, Milankovitch cycles became dominant about 1.5 to 2 million years ago. And for those who are listening who don't know what they are, they're perturbations in the orbit of the planet and the tilt of the planet, which are quite a complex set of interactions, which mean that the orbit goes from being elliptical to circular and back out to elliptical again. At the moment, it's highly circular, as it happens. We have the tilt will change. So, 24.3 degrees to 22 degrees, that sort of tilt, changing how extreme winter and summer are in the various hemispheres, and then precession, the actual pole rotates a bit. So those three factors to give you a very complex, chaotic system, which will determine how much of solar radiation we absorb at different points in the Earth's history, and therefore, when the combination is such that we have more extreme winters in the northern hemisphere, that leads to expansion of ice sheets. And so, if you look at the last 1.5 million years, roughly every 100,000 years, we've reached a peak in temperature, and then we've fallen back down again. So there's very, very, very roughly speaking, there's a 100,000-year cycle with 20,000 years of rising and falling temperature, 60,000 of constant, 20,000 of rising and falling. And humanity built its civilization on the peak of one of those hills. This is what people don't normally put in context.
Yeah, I agree with that.
Okay, so
we finally hit something I agree with there.
If we hadn't industrialized, then according to my friends who work in this area, the particular Milankovitch cycle we're on would have had a 40,000 year peak. We would have had 40,000 years of roughly constant temperatures before falling down into an ice age again. What we've done instead, by pumping out carbon dioxide, trapping solar radiation, warming the planet that way, we are now accelerating off we're now about 1.5 degrees above what was the peak, the pre-industrial peak. And that is pushing us in a direction where we're already at temperatures that haven't been seen since the previous Milankovitch cycle was called the Eemian period. And that's damage all our infrastructure, all the systems we have are designed for the very stable temperatures we had for the last 10, 12,000 years. And now what we're doing is dramatically moving out of that range. So the infrastructure I've built, the roads, the cars, the streets, the bridges, etc., were not designed for the volume of moisture that's now in the air. It's about 10% higher, if not more. So a large part of the storms we're seeing, and this is particularly becoming obvious in Europe right now. Spain is, part of Valencia got a year's rainfall in a day. That has never happened before in recorded history. So all these things mean the infrastructure just collapses. Bridges get wiped away. And with the stability that the climate gave us for that period of time is probably why we developed agriculture when we did. If you look back at the previous period, we're in what are called an interglacial right now. Dave would be aware of this, but the period we're living through now has glacial periods interrupted by interglacials when there's less ice, okay, because of the Milankovitch cycles. So what we've done is we've gone from 6 degrees colder up to the peak where we had the Holocene, where we could do sedentary civilization. Now that 6-degree increase in temperature means about a 40% increase in the moisture level in the atmosphere. So the ice age is drier. That sort of explains why we didn't develop agriculture back then. We developed agriculture at the point where the Holocene came in, 40% more rainfall than in the ice ages, more warmth, more areas where you could grow food. I don't think we could have developed a civilization during an ice age. We had to be nomadic. Now we've got a chance to be sedentary, but what we should have done is maintain that temperature indefinitely. We should have done geoengineering, okay, to maintain that temperature. Instead, we've been like an irresponsible kid just heating up the room.
We are going to disagree on that one at a level that's hard to imagine. If you think the Fed acts inappropriately, geoengineering scares there's no chance I want someone geoengineering our planet.
I think it's going to happen, Dave, because
I have no trouble imagining that.
Yeah, it's going to happen because irresponsible. Countries are going to decide, when we start seeing serious catastrophes, countries will start doing it regardless of whether you or I think it's a good idea.
Scares me. So there's a lot to unpack there. So the cloud cover issue is an interesting one because on the one hand, it's a greenhouse gas. On the other hand, it reflects light back into the atmosphere, and a number of papers actually fairly recently have come out and said, look, if you look at the reflectance that the cloud cover causes, it actually sends the light back away from the Earth, and it ends up having a cooling effect. So the clouds function to cool. So there's a beautiful potential feedback loop here where the Earth heats, you get clouds, and then all of a sudden the clouds start reflecting the energy back out into space, and it cools back down. And there's actually hard data on that. But I want to hit some of this disastrous stuff here. I'm going to do a share here, and you probably have seen all these plots, so I don't think you need to. I don't think you need a lot of time to see them. So
Do the same after yours, Dave. So roll away.
yeah, you're welcome to. And I'm just going to rapid fire a few things. Here's, for example, a plot of global hurricanes. Curiously, this was done by an undergrad, but using legitimate data. He's working with a legitimate group. There's no obvious change in the frequency of global hurricanes back to 1980. The problem has, as you say, well, as Bill might say, that's a short window. But if we are heading into catastrophe zone, then we should be able to see the frequency increasing. And certainly all the people throwing tomato juice on paintings, those people think they can see it, and it's not there. So let's go to a different, this one comes from Geophysical Research Letters. This is the frequency of hurricanes globally back to 1990, and it actually has a distinct downward trend. And if you think frequency is not the whole story, you can actually look at the accumulated cyclone energy, and that has a downward trend. And so in this modern era that's got everyone's underwear in a bunch, we're not seeing it. And I've argued with so many people saying, look, climate change could be roaring, but the naked eye can't see it. It takes a really good, careful analysis to see it. And they say, look, it's hot outside. And I go, just because your ass is sweaty doesn't mean there's climate change. Here's one that goes back to 1960. These are violent tornadoes. And again, downward trend. And this one comes from NOAA, which I'm told is credible. You might not like Roy Spencer because he's a very prominent climate denier, having formerly been in charge of the NASA satellite monitoring system. Here's one: continental U.S. landfalling hurricanes. The problem with the older data is you have to measure landfalling hurricanes because you can't monitor things that are out in the middle of the ocean back in 1900. So they use actually reports of hurricanes to get to this data. And as someone said, look, you can flip that chart over, you can flip it horizontal, and it would look the same. Here is an analog back to 2000 of this one makes me a little creeped out because I don't know what a global hydrological, climatological, meteorological disaster is. I do know Pilkey is considered the guy who did the most detailed study of these events and said, going back to 1900, you can't pick up signal. So then you get heat waves, for example. So let me ask you this
heat
question.
Waves, mate, this is one of the problems. Heat waves in the United States, that's not global temperature, okay? And that's one.
No, that's correct.
Okay,
that's
so if
correct.
you global, I'm going to show global temperature in a moment. So this sort of stuff, when you have regional stuff and regional levels, even including cyclones in America, you are cherry picking part of the surface of the planet.
There's global droughts.
Yeah.
And again, the naked eye should be careful about looking at that thinking that they can see a pattern, but the naked eye doesn't have trouble failing to see a pattern, I think. And those of you who are listening to this on record mode, you should be ready to click pause while you stare at these if you wish. And then here's a good example. So one of the things I ran into that bothered me to no end is that I ran into a lot of fibbing. I really ran into a ton of fibbing. And this is one of the examples that drives me most crazy. Here's a plot of forest burn versus time, and it's cumulative. Now, first of all, what I can tell you is you should never do cumulative. Not never, but most things you shouldn't, because, for example, if you looked at the cumulative deaths from cancer, you would easily conclude we're losing the war when in fact we're winning that war. So Hayhoe, you must know Catherine Hayhoe, posted this thing, and I went through it and I said, look, figure 26 looks like fraud to me. And she got mad at me. And she said, you have to go read the paper. And I went and read the paper. And what I didn't like about this, besides the cumulative thing, is that this idea that they could dissect the burn acreage from natural. And one of the problems is burn acreage depends on something more profound than temperature, and that's land management. And so I do not believe this is even possible. I went to the original paper, and what they had done is something that to most people would seem so trivial. At the y-axis, it was exactly the right data, but the y-axis they took off the word modeled. Now we know that everything is a model in this world, but the word in climate change, difference between data and model is a huge difference. And they took off the word modeled to get rid of that nasty word. And that bothered the hell out of me. And that's the kind of stuff I keep running into now. This starts in 1985. And you could say, well, I can see it. It looks bleak. I can see an upward curvature. That's what happens if you pan back to 1926. Now, this is not Southeast. This is U.S. Now, you got to wonder, if you look right where they started their data, it's right about here that they looked at the Southwest. So I'm starting to get to these guys lied their asses off mode in the competition, right? And if they had moved back, they would have shown the rest. And to me, that's sort of on the edge of fraud. And when people lie to me, I go, why did you just lie to me? And now here's the other problem is, again, we're back to land management. Burn acreage doesn't in any way attest to land management. And the cost of the economic analysis of hurricanes drives me nuts, because that's all land management. So I stay away from that. So in any event, I'll let you rip now.
Now is the time to take advantage of the power of gold and silver to grow your wealth, whether you're an experienced investor or new to the game. These precious metals have a long history of being a safe haven for your savings, but they also offer growth potential, making them a wise investment choice. So where does the average investor go to buy gold and silver? That's easy. JM Bullion. JM Bullion is one of the most popular and most trusted precious metals retailers in the nation. We offer a huge selection of gold, silver, platinum, and palladium products that can be delivered to your door in safe, discreet, fully insured packaging. From 1 gram of gold to an entire mint box of silver, JM Bullion offers precious metals to suit every financial goal and budget. No matter your budget, now is the time to start investing in precious metals and start protecting yourself and your savings against these volatile markets. Visit jmbullion.com today to take a look at our wide variety of precious metals, rounds, coins, and bars, and find out how you can turn your savings into gold.
But I also don't think the temperature's soaring the way you say, but we can get back to that.
So that's what you said, the hockey stick's been invalidated. No, it hasn't. That's the most recent data. That's not Michael Mann's. That's I've forgotten the actual author, but I've got it embedded in my presentation that this comes from. And what you see is that we have that's pretty much where the period of industrialization began. This period here.
Who put that out? I need to know who put that out.
Okay.
Do you know who put that out?
That's data going back to the year dot. That's recorded data. Obviously, this is proxy data. But that's when Industrial Revolution began, and we see the increase in temperature from that point. But my main focus is looking further back in time and seeing when was the period that we went through building sedentary civilizations. We began about 10,000 or 12,000 years ago. That's Cheops Pyramids construction date. That's the Göbekli Tepe, the oldest known mesostructure created by humans, just discovered in Turkey in the last few decades. So that's entirely the period in which we built our industrial civilization, agricultural and industrial. Now, when you go back further, this is now showing the ice age, the previous ice age. So that's the last time we had a glacial, and this is the interglacial period, and that's 6 degrees colder than now. So people who think, 6 degrees isn't all that much. 6 degrees in the other direction to heating puts us back in an ice age. So the small changes in global temperature have a large impact upon what is feasible for civilization. And that's where civilization has existed. You can now see that because I'm taking a much longer time scale on the x-axis, the increase in temperature we've done now is much more obvious. And if you go back to the last million years, those are the Milankovitch cycles. Now, again, we need this long-term perspective because we only evolved about 300,000 years ago. Those are the various peaks over the last million years, about a dozen of them. That's when we evolved as a species. So we've only had 3 peaks since then. And only in the very last one have we built advanced civilization. And if you go back further again and say, when did this happen? This period of glacials to interglacials is a very recent phenomenon in the Earth's history. And we happen to evolve in the middle of it. If you go back further again, that's when the ice ages began. So we didn't have ice ages before then. Go back further and go back 70 million years, you see the period when the dinosaurs were around, obviously. But this period we're in now is an extremely strange period in the planet. High temperature, low temperature, high temperature, low temperature. Okay? That volatility didn't exist. We had a declining temperature over time, all sorts of factors behind that, again, and mainly, of course, astronomical factors. That's when the dinosaurs went extinct. Now, coming back to the previous picture that I showed, everything we've done has been on this hill. And that's why I say we should have considered geoengineering to maintain that temperature, because if we'd had, everything we built would have worked. We could have ended up in what I call the Jetsons future. There's the sort of stuff we used to see as kids in cartoons, If we didn't do it, and it would have taken longer than I show here, but without global warming, we would have gone back into an ice age again, and these bastards would have, taken over the planet once more. But instead, what we're doing is boosting it up at 30 times the rate of change of the Milankovitch cycle. And that's the part that I think is potentially suicidal. We really have no idea what's going to come our way, but that rate of increase in temperature is going to destroy the capacity for us to maintain the infrastructure we've built on the planet that was predicated on that very stable period that is now over. And that's the real danger of climate change. We've built in a stable period of the climate. We're destroying that stability and thinking we can still have the social system we've designed. And I just don't think that's true.
So let me
Go ahead, Dave.
go ahead, Bill.
No, I wanted you to see if you want to say something, but I would like both of you to discuss one point that I brought up earlier that you said we'd be sure to get to, and that is, as a layperson who's not intimately involved in this, but as someone with a strong math background and interest in science, I'm always curious to know why the topic of the sun and the solar cycle and solar minimums and all of that sort of thing is never brought into this equation.
It's because scientists already know that shit. I mean, people think scientists haven't thought about the cycles on the sun or haven't thought about Milankovitch cycles. It's all built into their models because they've known about that for decades. I mean, Milankovitch cycles go back about 80 years, I think.
But simply because they know about it doesn't mean it can be dismissed without discussing.
It's not dismissed. It's included in their models.
But I'm asking you guys to talk about it for the people that are listening.
The answer is that, and this is where things like radioisotope dating, radioisotope measurements come in for the scientists to clarify what's actually causing the change. Is it our carbon dioxide? Is it somebody else's? The answer is it's our carbon dioxide because of the isotope balance of the type of carbon atoms which are increasing the level of carbon dioxide in the atmosphere. So we know it's not volcanoes. It has to be human generation of carbon dioxide. And then again, just like the Milankovitch cycles are a known factor and included in any decent global circulation model as to what's going to cause the temperature over time, so are solar maximums and minimums. Now again,
so you don't believe in the global warming period, the medieval warming period, for example,
but it happened in England. It happened in England. It was not a global phenomenon. It was something which occurred in Europe. Okay, that happened.
Why does it show up in the Greenland ice cores then, for example? Why does it show up? Why does it show up in the tree ring data in the United States? Why does it?
I'm not questioning the data from scientists. I am very vociferously challenging the so-called data by economists, and I want to talk about that as well, because the economists have done the worst work in the history.
We don't believe the economists. We can accept that.
Okay, well they've bullshitted, and they're the ones who've actually spread the doubt and
the
confusion.
I mean,
I'm sorry. Scientists measure carefully. Okay, I've had plenty of experience with scientists. As I said, they're by nature they're anal. They call themselves lab rats half the time. They've been people involved in doing careful measurement. They try to include all the factors, Bill, including the solar minimums and maximums. They're quite aware of that. It's hard work programming that stuff into their systems. one of the problems is most of the programming is still in Fortran, which makes it very hard to maintain the code, but they definitely do all that work. So, like Dave, you can find, yes, you'll find regional impacts. I was showing you global data beforehand. Okay, the global measurements are what matter. Local regions can rise and fall for all sorts of reasons. And I'm not an expert on Greenland's past history, so I'm not going to say what I think caused that
Well,
change. If you show me,
but then
I'm
you
showing you global
okay,
data.
okay.
You're challenging me with regional data. It's not the same
No,
language.
well, because you assemble it together. They were growing hops in England 600 years ago. In places they weren't growing hops. The medieval warming period wasn't just the United States, wasn't just Greenland, wasn't just Europe. It was all over the place. I don't know about China. China's a blank slate for
Well, in
me.
fact, if you look at the data,
But the plot you showed me, the plot you showed me that you showed where it's spiking, the temperature spiking like crazy, is a completely foreign plot to me.
I showed you a moment,
it's a completely foreign plot to me.
The data that I showed a moment ago, and I'll just actually go back and get it on my screen properly. When you look at that the data for the last 2,000 years, there is a period, the period about 500 AD to about 1000 AD was a time of much warmer temperatures than now. And that was quite possibly, that's part of the Milankovitch cycle. We had warmer, the maximum temperature, pre-industrial maximum temperature, was between 500 and 1,000 years ago. So it was warmer.
Didn't we die?
That's part of the Milankovitch cycle. That's why it was warmer.
Why didn't we die? I mean, by your model, we should have died.
Because we're talking half a degree or a quarter of a degree over the planet. We're not talking 3 degrees. And that's what we're headed towards at the moment.
The temperature of the planet has oscillated in a range much bigger than 3 degrees.
Of course it has. But we evolved when it was 6 degrees colder than now. Okay? Our temperature range, we're not dinosaurs, mate. We may become like dinosaurs. So yes, the temperatures have been different. We weren't here for it. We may not be for it in the future. So the fact that the temperatures have been different doesn't particularly suit us. If we were Tyrannosaurus rexes, I'd be looking forward to an increase in temperature. We're not. So, the fact that the temperature...
we live, let's put it this way, we live in a temperature range that varies from minus 90 to 120.
You're talking Fahrenheit, of course, across the surface of the planet.
I grew up in America. I'm stuck with Fahrenheit.
Well, I'm going to say what's 14 degrees convert to as in Fahrenheit? What, about 50?
14? No, it's
55?
less than that. It's about a factor of 2.
Yeah. Okay. No. That's the global temperature in which we evolve. So again, you're making a geographic comparison when what matters is over time. And though we, like as humans, we live from we have Eskimos in the Arctic, and we have Bushmen of the Kalahari in the warm parts of the world. We can evolve across space easily. Okay, it's evolving through time that is the challenge, and that's what we're doing. And we're changing the level of the global temperature 30 times faster than it would happen now normally. And if the normal cycle would be going colder, not hotter. Now, can we maintain our infrastructure with that rate of change of temperature? Is our infrastructure designed for, let's say we go to 3 degrees of warming, for a level of rainfall, which would be 25%, or level of moisture in the atmosphere, 25% higher than we've built our infrastructure for. And looking at the storms in Valencia, when you're talking about 10 or 12% more moisture, I'm sorry, I just going to see that level of weather volatility destroying the capacity for sedentary civilization. And that's the main reason that climate scientists are so terrified, because they can see that we're amateurs. Okay, both of us, all of us are amateurs here. But the scientists are saying this is scary for the potential survival.
I got this scientist.
And I trust the scientists. I do not trust the economists. I trust the scientists.
I got to jump in here. I've lived with scientists my whole life. I was an editor for 20 years. You're deifying scientists. These guys can be full of shit. They really can be completely full of shit.
We saw it with the entire medical community during COVID. I mean, just because you're a scientist doesn't mean that you're infallible.
No, but you're not infallible, but you're a damn sight less full of bullshit than economists and social science people.
Well, we'll give you that much. I'll give you that much.
Okay. And I've dealt with economists. Believe me, I know shit when I see it, and I see shit coming out of economists.
Right above the economists, I'll put a toaster oven.
No. So you got economists and politicians, and they're all full. They're almost all full of garbage, okay?
Yeah.
Scientists operate on a higher level, but they're still people. And people, I don't care how diligent you think everyone is, people are still subject to peer group pressure. And we just saw the great experiment during COVID. So just because you're a scientist doesn't mean you're immune to foibles. That's, you know.
Yeah, but they have corrective mechanisms for foibles that we don't get in the social sciences. And that's one of the major reasons they end up.
But we don't.
What we're doing is we're disputing the experts here. And I'm happy to fight economists, as you know, on tooth and nail everywhere. But to think I'm going to fight scientists in general, say scientists have got it wrong, and us people in the social sciences know better, I'm sorry, I think that's full of shit.
Well, we're going
to have to just disagree. We're just going to have to disagree then. I'm marinating
find out. I mean,
I'm marinating in science. I agree with you.
Yeah, this thing, we're going to find out, okay, because all the attempts by people like the Limits to Growth initially, the Club of Rome study and so on, through to the climate scientists now, nothing of that has changed the direction of human civilization. We're still...
Well, see, I agree with you on the Club of Rome.
Okay.
Right? That's a resource depletion argument.
Sorry?
And the Club of Rome is both a resource depletion argument and it's a world carrying capacity argument.
Yeah.
And I don't have the answer, but I do believe in the Albert Bartlett, exponential functions poorly understood.
Yeah, true.
And so we're on the same page there. Again, I think Bill knew where he was going. I think that when you dig into this, you find that you can explain almost all the temperature movements by the sun, all of them.
Oh,
and here, let me point out something interesting.
I did an interest waiting for you, Dave, if you want to prove that, because there's a vast majority of scientists who are going to say you're wrong.
I don't know what the IPCC currently has, but at one point they had no solar physicists. So I went looking for solar physicists who signed off on the climate narrative, and I could not find them. So I started asking guys I know, and admittedly from the denial side, I said, do you know a solar physicist who's out there battling? And so the other day for fun, this is an entertaining experiment, I searched climate deniers using AI, right? And we know that AI, you're squeegeeing the floor of the internet for drippings, right? I get that.
Yeah.
But I searched, give me 10 climate deniers, prominent scientists who are climate deniers, and it gave me the 10 that you and I could both name, right?
Yeah.
And then I said, give me 20.
Yeah.
The whole enchilada, right? Yeah. The whole Patrick, what's his name? Patrick Moore, Michael Schellenberger, a whole enchilada, right? And then I said, give me 20. And I got another 10 that I recognized, right? And then I did the funny experiment. I said, and then it also describes what they say. And then I said, could you give me 10 solar physicists who think that climate change is a crisis? And the money line came back and said, there's no definitive statements made by solar physicists. And then it proceeded to give me a handful, which were these milquetoast statements that disputed something that were not relevant. I'm going, AI can't even find solar physicists who don't buy. The solar physicists like Nir Shavim, these guys are pointing up to the sun going, that's it. That's where Bill is heading from it to equal zero.
I've got a feeling that's the inadequacies of ChatGPT and so on, rather than
no. But but I've tried to find them.
Well, I'll go looking as well, Dave. I'll do you a favor and order that search on academic journals.
Send me some. I'd love to get it. I've tried to find them. I've asked people for help.
We've got a solar maximum right now. Okay, that's one thing I've seen in literature recently.
Oh, I agree.
Okay.
I agree. Which means we're about to get cold.
In no way
we're about to get cold.
Is that explaining the temperature gradient we've seen from 1750? And that's when the data turns up.
Your temperature data is so utterly unfamiliar to me. So either something,
I'll find
every other. No, you don't have to put it up again.
No, I just find the reference for you.
Okay, but while you're doing that, gentlemen, it's time to start wrapping this up as we're heading to the end of our time.
Bill, let me do you a favor here just for a second. You asked about solar cycles. There's just hundreds of studies of the relationship of solar cycles to temperature. So here, for example, Milankovic cycles, that shows the average person who hasn't looked at this how rhythmic they are. They're really extraordinary. Here's a plot of Milankovic cycles versus sea level rise. And again, pause your screen if you're watching this on record mode, but that correlation is really pretty cool. Here is, and I don't know, I think they used the Oman Holocene period for a reason, having something to do with a crazy ass cave experiment where they had to go down in a cave to measure something. But this shows the Holocene temperatures versus cosmic rays. And they can measure cosmic rays using isotope effects in the rocks and stuff like that, and in the soil. And that's an amazing correlation. There is 400 years of solar activity versus temperature. Now, the problem is your temperature plot that I said I've never seen before doesn't fit on this plot either.
I'm sure yours looks
and the
wrong.
problem is this plot goes, well, this goes to 2000. Yes, it does. Fensmark is a scientist. And then here's the one. This is now what's amazing about this plot is that these two curves were generated from completely independent fields. They had no idea what each other were doing, and then they said, "Holy cow, let's overlap these." And these are the temperature as measured by isotopes versus cosmic rays over 500 million years. It looks like the sun to me. And let me see if there's anything else. That's nothing. Okay, we're done. I just wanted to rip through those. Okay. That's why Bill asked about solar cycles. That's why I think they're solar cycles. And I think humans are contributing. But there's some very, very famous physicists who are on my team, just for the record.
Mate, I hope your team is right. It's a non-argument. If my team is right, we're dead. If your team is right, we continue living. So I hope I'm wrong. But what I've seen, all this stuff is just contradicting the general trend of scientists to be driven by empirical data.
Let's have the final topic be to the Green New Deal to arrest the problem that we're discussing, and so Dave, you can talk about your view of financing the Green New Deal, the efficacy of it, and then Steve can give his verse, have the final say on the subject. How's that?
This is a simple one for me. My dad taught me this when I was a kid. Never ask the government to spend your money. They'll do a terrible job. If we were serious about climate change, let's say Steve's right. Let's say the insiders know this. They should never have put guys like John Kerry in charge as climate czar. This is farcically bad. So government's not going to solve this problem. What have they done? Well, it's not going to last, but they've handed it over to John Podesta. My head just blew up. I just splattered my screen on that one. Pizza Boy. I think we are going to squander enormous amounts of money doing things the way government does. And Steve could be 100% right, and we are still going to screw that pooch like there's no tomorrow. Now, here's the thing that bothers me about Steve's view. Steve's enthusiastic about intervening as scientists. But here's the question I have is, who is going to make these tough calls? Who has the right to sign off the informed consent, as Brett Weinstein talks about, to say we are going to cover the world with a blanket of particles to block the sun? And when we do that, how are those solar panels going to work, right? That sort of thing. So I don't trust humanity to collectively solve this problem with a big government project. And so even if you're right, I don't want them touching the goddamn thing. I would rather save the resources. And it's not about money, because money's fake. We know that. It's about human resources focused on trying to minimize pain and suffering. I would rather put it towards adaptation.
Yeah, well, I think we're going to lose anyway. I think we've had it. I think civilization will be lucky to make it to 2050. I know, speaking to my climate scientist friends like Tim Lenton, for example, who's a global expert on tipping points, he was asked, what's the chance of civilization lasting to 2100 at a conference? And Tim is normally very taciturn. He said, not a chance. The way we're going, not a chance of civilization lasting that long. So what you're doing is taking a gamble with the existence of civilization. Good luck. We both need it. I think you're wrong. I hope we don't find out during my lifetime, but I think we will. And so I'll go on record on saying that if we continue down the trends we're doing right now, if we take the perspective you're taking, that it's all just a beat up and the data's not that bad and we can handle that temperature, then we're going to destroy civilization before 2050.
Well, on that cheery note, I guess we'll end this. But the good news is we don't have that long to find out for those of us who don't have as much gray hair as the three of us. Dave.
Indeed.
I didn't think we were going to make it to November 6th, so I'd say he's an optimist.
Anyway, thanks a lot, guys.
Okay.
Thanks, Steve.
Thank you. Good to meet you, Dave. Happy to disagree with you. You're a good bloke.
Yeah, that's fine.
Okay.
That's fine.
All right, so I'll see you later.